So in our last class, we started linear programming, and I mentioned to you that linear programming represents the process of allocating limited scarce resources among competing product line in a judicious and efficient manner in order to achieve the organization's single economic objective. And I said that linear programming is used to allocate resources when more than one factor of production are limited in supply. When you have multiple constraints, when there are multiple constraints, that is when linear programming is used to determine optimal production plan that will enable the company to maximize contribution towards profits. For example, raw material kilogram may not be sufficient, as well as raw material kilogram including labor hours, may not be sufficient to maximize contribution towards profit. It is also possible that labor hours and machine time may also be inadequate that will enable the company to take advantage of market conditions. So when you have multiple constraints, you need linear programming to allocate the limited scarce resources among competing product line. Remember, you will recall that when we had optimal product mix, we said key limiting factor is used when there is only one constraint, when only one factor of production is limited in supply. That is when you use the key limiting factor, that is optimal product mix. But when you have multiple constraints, when more than one factor of production is limited in supply, you need linear programming to allocate the limited scarce resources. And I also mentioned that there are about 5 or 6 underlying assumptions of linear programming. One is single economic objective. The single economic objective states that there must be only one objective to be achieved, either to maximize contribution or to minimize cost, but not the two, okay? In theory, that is what the assumption says. Then number 2, divisibility, which is also known as fractionality, which states that fractional output can be produced and that it is not compulsory that you must produce the entire requirement. You can take 70%, for example, you can take 80%, you can produce 99%, you can produce 100% of the required output. It's not compulsory that you must produce 100% of that particular requirement or output. So that is what divisibility is talking about. The third assumption is linearity, which assumes that the relationship between the objective function and other factor of production must be expressed in linear fashion, okay? The relationship between the objective function and other factors of production must be expressed in linear fashion. Then number 4, talk about linearity. Okay, I just mentioned linearity. Then certainty. The fourth one is certainty. Okay, the certainty assumption is premised on the fact that the required resources or the factor of production required to produce the company's final products must be known in advance and with certainty. I will take that again. The certainty assumption states that the factors of production required to manufacture the company's final products must be known in advance and with certainty. What this is trying to say is that before you go into production, you must know the material kilogram that will be needed for production. You must know the labor hour or machine time you are going to need for production. You don't get to the production process before you decide how many kilogram or how many machine hours that you are going to need. So you must know the required resources in advance and also with certainty. You must know what is required for you to produce your final product. The number 5 assumption is non-negativity constraint, okay? The 5th one is non-negativity constraint, which states that there cannot be negative output and that the least that can be produced is 0, okay? Negative output is not permitted. You cannot have negative output. The least a company can produce is 0. And you know, when a company produces 0, it's as good as it does not produce anything. So those are the underlying assumptions of linear programming, which we discussed in our last class. Then we now begin to talk about the procedures involved in determining optimal production plan using linear programming. The first procedure you are going to do is to define the variable. Okay, you define the variable, which means what I mean by that is that at times, in fact, in most cases, the products to be produced may be given to you in words. Example, like for example, the question we wanted to solve the other time, Akanchawa, where you have Toro Kobo. In one of your past questions, examiner also gave to you smally, biggie. So you don't use that to represent. So you have to convert it to letter. It could be A and B. It could be B, it could be X and Y. It could be M and N. So you have to represent the words in letter. That is what definition is talking about. So you define the variables. Then step 2, you formulate the linear programming model. When you want to formulate the linear programming model, there are 3 procedures you are expected to carry out. The first procedure is to state the objective function. Then step 2, you state the relevant constraints. Okay, you state the relevant constraints. Then step 3, you state the non-negativity constraint. Then step 3 of the optimal production plan is to bring out the equation and solve using elimination method. Okay, that's what we discussed last time. Bring out the equation and solve using elimination method. So I just want to brush you through what we did last time. So when we are solving question, I'll be making mention of that, and it will become a reality because we are going to be practicalizing it. But for now, let me finish the recap on what we did last time. Okay. I don't know what happened that supposed to be automatic joining. In any case, let's move on. Now, I said step 3 of determining optimal production plan is to bring out the equation. The equation you have in step 2, where you have the constraint. Okay, so you bring out the equation that you solve using elimination method. Then step 4, you construct a pivot table. Step 5, you construct a solution, you construct a graph. Okay, you construct a graph, that's step 5. Then step 6, you construct a solution table. Step 7, you determine the optimal production plan. Then step 8, you determine the profit derivable. These are the procedures involved in determining the optimal production plan. Like I said, when we have live question, I will be demonstrating that so that it can sync. This is just a recap on what we did last time. Now, it is also possible examiner may ask you to determine shadow price. Okay, you may be asked to determine shadow price. So shadow price represents the extra contribution derivable from the additional unit of limited scarce resources that have been fully utilized at the optimal level of activity. The optimal level of activity is the point at which the decision is made. At that level, where decision is made is where you are going to have binding constraint. The binding constraint is the optimal level of activity. Therefore, there are 2 procedures, or there are 2 methods that you can use. There are 2 methods that can be used to determine shadow price. You can either use dual method, or 2, you use increase the number of constraints by 1. Whichever of the 2 methods that you use, you are going to arrive at the same answer. Okay, you will arrive at the same answer. So we are going to demonstrate the 2 as we proceed so that you understand whichever one that is more convenient for you. But at all time, I will advise you always use the dual method, because the dual method is straightforward, unlike the increase the number of constraints. Increase the number of constraints as series of stages, okay, a series of stages, and to waste your time. So it's better you use the dual method. Examiner cannot tell you to use any of the 2. So you are at liberty. You are the one that will decide which one to use. Examiner cannot tell you to use dual method or use the increase the number of constraints by 1. Okay. All right then. So let's have illustration. Before that, let me have a question. Let me know if you have any question for me. Any question? So we are going to be strategic in the way we solve questions going forward because of time. All right. So we are going, like I said, we are going to do two illustrations, but let's solve this latest question first. Once we are done with that, then I will now use another question to support it. So this biggie question, you can just go and try it. Go and try biggie. Go and try biggie. All right. That's not the one I want to solve today. Let's solve the latest one on linear programming. This, Oshimiri. All right. Okay. Yes. Who can help us to read, please? Who will help us to read?
Good evening, sir.
Yes, Amarachi, thank you. Go ahead.
Oshimiri Nigeria Limited, a company based in Aba, produces two grades of industrial varnish. The selling price and associated unit variable costs for the grade A and grade B are shown below, and the information below are said to be correct. The fixed overhead costs are 2,600,000 naira per month. The company plans to maximize profits. The availability of resources for the following month is as follows, and the information below are said to be correct also. Required: A, identify the objective function and the constraints of the model to be used in determining the optimum production plan for the following months. B, determine the optimum production plan for the month and associated profits. C, explain the concept and significance of dual prices and slack variables in the context of the model used by the company in this scenario. D, calculate the dual prices for the constraint identified in this scenario. And lastly, suggest the ways in which the identified model may be used to overcome capacity constraints during the following month, and indicate the types of costs which may be incurred in overcoming each constraint.
Thank you very much, Marachi. That is the question. So without much ado, in the A requirement, you have to identify the objective function and the constraint of the model to be used in determining the optimal production plan for the following months. What examiner is simply asking you in the A requirements is to formulate the linear programming model. In the A requirement, you are expected to formulate the linear programming model. Please open to the material at your end so that I can switch to the working note, please. So you want to formulate a linear programming model. So what are you supposed to do? All right? What are you supposed to do? Yeah. This is illustration number, let me see. Illustration number 6, page 48. Okay. Solution to illustration 6, page 48. All right. The name of the company is Oshimiri Nigeria Limited. Oshimiri Nigeria Limited. Okay. So examiner is asking you to identify the constraint and just formulate the linear programming model. Okay. So if that is the case, when you look at the question, you will see that examiner has given to you grade A and grade B. So you are given grade A and grade B. So in that case, no need to waste time. I want to formulate linear programming model. I would then say formulation of linear programming model. So step one, whenever you want to formulate a linear programming model, there are three stages, there are three steps. Step one is to state the objective function. Don't go on the day of your exam. Don't say state the objective function. Just write objective function. Move on. Don't need to say state the objective function. This is what you are expected to do on the day of your exam. Step one, objective function. And don't go and be saying step one, step two. All those ones is not needed. Just go ahead straight. Objective function. Therefore, what objective do you want to achieve? You go to the question. If in the question you can see contribution, or you can see profits, or you can see selling price and variable cost, you need nobody to tell you that the company wants to maximize contribution. But if in the question, no contribution, no profits, no selling price, all what you can see are costs, it means that the company wants to minimize costs. So you must note that. Then let's go back to the question. Immediately after the table, examiner has told you that the company plans to maximize profits. So that means the objective function is to maximize contribution. So in that case, I need to go and determine contribution per unit for each product. Okay, so here is maximization of contribution. There are two products, grade A and grade B. So I need to determine contribution for each of them. Examiner did not give us contribution, so you are the one that will determine yourself. So let's calculate contribution per unit first. This will be, we are going to create about 3 pages, 3 or 4 pages. Okay, then we start our working on the 5th page. So I will then come here, workings. Because working should be the last thing you are going to, on your answer booklet, should be the last thing. Should not be the first thing you are going to do on the main page of your answer booklets. So working number 1, we want to determine contribution per unit. How do you determine contribution per unit? You know that contribution is simply selling price minus variable cost, or fixed cost plus profit. So in this question, there is no fixed cost plus profit. Examiner give us selling price as well as a variable cost. Therefore, we have A, we also have B. All right, so selling price. What's the selling price for grade A? What's the selling price?
2,100.
2,100. Grade B?
1,500.
1,500. Then you less variable cost. What are the variable costs given to us in the question? Do you have direct material?
Yes.
So we have material. How much is material?
For grade A, 480.
480. For B?
For B is 240.
240. Do you have direct labor?
Yeah, we have skin labor, yes.
Skilled labor, direct skilled labor. Skilled labor. How much is A?
720,
720. B?
288, 288.
2888. What next?
We have
After
unskilled labor.
unskilled labor.
Unskilled labor,
How much is A?
120,
120.
and B
B?
is 188.
180. 188.
Yes, sir.
Okay. Then after unskilled labor, what do you have there?
We have variable overhead.
Variable overhead. Okay. Variable overhead. This is 180. Variable overhead. How much is variable overhead for A?
168,
168. For B?
336.
336. Any other ones?
No, that's all.
Oh, yeah. Find me the hiatus, the difference.
The contribution for A, grade
Yep.
A, is 612.
Pardon?
The contribution for A is 612.
612. For B? For B?
448.
448. Okay. So at this point, now that we have determined the contribution per unit, the next thing we need to do is to state our objective function. But before that,
Sir, excuse me, sir, I got 456.
456. Okay. 456. Let me confirm.
You have to check again.
1,500 minus 240 minus 288 minus 180 minus 336 equal 456 is the answer.
188. 188, not 180.
It's 180. It's 180.
It,
It's 180. 456.
oh, it's 180. Okay.
So thank you. That's 456. Now that we have calculated the contribution per unit, the next thing we need to do, examiner has given to us the maximum available for each constraint: material kilogram, skilled labor hours, unskilled labor hours, as well as machine hours. But we don't have the material kilogram per unit, labor hours per unit. So we need to calculate that. Okay, working two. We want to calculate material kilogram. We are going to mix everything together. Material kilogram, labor hours, and machine hour. Machine hours per unit. So we are going to use a table to achieve that. That will save time. So we have grade A, then grade B. So the first one is material kilogram. Before this, let me do this. Let me give you the format or the formula. Remember, you recall that when we had optimal product mix, we said that the factor of production to be used should be material kilogram and labor hour or machine hour, that you don't use material cost. You don't use labor cost. So when you are given material cost or labor cost, you need to convert it to material per kilogram and then labor hour. So how do you do it? We've done it before under optimal mix. So to determine the material kilogram is material cost divided by material per unit. So that will give you the material kilogram. Labor hour, whether labor hour or machine hour, is the same way. Labor hour is computed as labor cost divided by labor rate. So let's use a table to do this. Grade A, grade B. Material is the first one, material kilogram. How do you determine material kilogram? Let's go to the question. We even have it up here. So from the question, material cost is 480 naira. Therefore, you say 480 divided by, what's the material per unit as given in the question?
240 per
240,
kg.
240 per kg. So here is 2 divided by 240, which is equal to 2 kilogram. Then for B, that's 240 divided by 240.
That's 1 kg.
240 divided by 240 equal to 1 kg. So I'm done with material. Next one is skilled labor. Under the skilled labor, the skilled labor cost is 720 naira. What's the labor rate?
The labor rate is 144 naira.
144 naira. Therefore, 720 divided by 144. What you get?
5 hours.
5 hours. Here is 5 hours. Then for B is 288. 288 divided by 144, which is
That's
2
2 hours.
hours. Next one is unskilled labor. Unskilled labor for unskilled labor, A is 120 naira. What's the labor rate for unskilled?
60 naira.
16
Divided by 60, which is 2 hours. Then 180 divided by 60 equal to 3 hours. Then we also have machine hour. Machine hour, examiner told us that the machine hour is based on variable overhead. We are told that machine hour is based on variable overhead, and how much is variable? How much is that? Variable over 84 naira per machine hour. Okay, 84 naira per machine hour. Therefore, 168 divided by 84. 168. Let me write that. Divided by 84 equal to 2 hours. Then the other side, 336 divided by 84 What do you have there? That's
4
4
hours.
hours. So that's that. That's that. Okay. This is how to determine the material kilogram and then labor hour per unit. So now that this is done, the next thing we need to do is to go back to our formulation of linear programming. Hope you know all this number offhand because I'll be calling for it. Okay. So maximization of contribution. Contribution of A is 612. You then say 612 naira of grade A plus 456 of grade B. So with this, I've stated the objective function. The next thing we want to do is to state all relevant constraints. There are 4 different types of constraint in the question. You then say subject to what are the constraints? The first one is material. Material kilogram. According to the question, we are told that material kilogram is limited to 25,000. Is limited to 25,000. Therefore, what's the material per unit? Material kilogram per unit of A in our workings?
2 kg. 2
Pardon?
kg.
2
2 kg.
Okay, 2 of A plus what about B? 1
1.
kg. So you don't need to say 1 kg, just say B.
Okay.
All right?
Yes.
Because we are maximizing contribution less than equal to 25,000 kilogram. So with this, we have represented our material, the constraint on material kilogram. The constraint is that material kilogram is limited to 25,000. So this is how to do it. And then again, you express this in linear fashion. When you express something like this, that is what is called linearity. All right, that's what is called linearity. Then the next one is skilled labor. For the skilled labor, what's the first one we got?
We got 5 hours for grade A.
5.
2 hours for grade, yeah.
So
5
5
A
of A plus
plus 2B.
2 for
2B
B less than equal
is
to
equal to 38,000 hours.
48,000 hours. Next one is unskilled labor. For unskilled labor, what do you have for A?
We have 2 hours and 3
So
hours.
2A plus 3B less than equal to
39 hours.
39,000 hours. Then the last one is machine hour. So what do you have?
We have 2 for 2A,
2A plus
4B,
4B less than equal to 50,000
50,000 hours.
hours. So with this, we have stated all relevant constraints. We have stated, when you do this, these are the constraints. We have stated all relevant constraints. Then the last thing you are going to do under formulation is to state the non-negativity constraint. You then say non-negativity constraint. The non-negativity constraint states that negative output is not permitted and that the least that can be produced is 0. Therefore, you then say product A and B must be greater than or equal to 0. Okay, whatever you are going to produce for product A and B must be greater than or equal to 0. This is how to formulate a linear programming model. Abdulatif, talk to me.
Good evening, sir.
Good evening.
Sir, please, for God's sake, I just need you to recap again how you came about less than equals to 25 kg, 48 kg, 39,000 hours, 50,000 hours. Please.
Is there in the question? Maybe you are given the kilogram. You are given 48,000. You are given 39,000. We are not the one that determine it. Is there in the question?
The available resources.
Yes.
Yes, sir. Thank you, sir.
You are welcome. Now, so with this, when you do this, you are going to pocket your 5 marks. Remember, this is 5 marks. So with this, you pocket your 5 marks. Then you move to the next one. The next requirement, examiner told you that you should determine the optimal production plan for the month and then the associated profit, another 5 marks. This is a cheating. That number B should be more than 5. But again, examiner understand the fact that the A and B ordinarily are supposed to be together, but examiner intentionally separated into 2. But that notwithstanding, let's move on. So you want to determine optimal production plan. So what are the procedures? I told you whenever you want to determine optimal production plan, the first thing first that you need to do is to formulate the linear programming model. You've already done it in A above. That's what the examiner wants you to do. So I can just come in and say, determining optimal production plan. So when determining the optimal production plan, the first thing you need to do is to state is to formulate the linear programming model. We've already done that. Therefore, I will just go straight to step 2, which is to bring out the equations. Okay, I'll use it as 1. So there's no need for you to say bring out the equation. It's a waste of time. Don't do that. You can just say equations. To bring out all the equations. So equation 1 is 2A plus B equal to 25,000. All right, that's equation 1. Equation 2 is 5A plus 2B equal to 48,000. The next one is unskilled labor, which is 2A plus 3B equal to 39,000. That's equation 3. Then the last equation, which is for machine R, is 2A plus 4B equal to 50,000. That's equation 4. So these are the 4 equations we have under the linear programming model. So you now solve the equations using elimination method. So again, there is no need for you to say solve using the elimination method. Just continue to do what you need to do. So, or you can say elimination. So the first equation is 2A plus B equal to 25,000. That's equation 1. So to eliminate, what you are going to do here is to eliminate one variable and keep the other variable alive. So you can say let A equal to 0. You know, if A is equal to 0, 2 multiplied by 0 will give us 0. So if A is equal to 0, then B is equal to 25,000. That's the answer for that one. Then since you know you already have answer for B, then you now say again that let B equal to 0. If B is equal to 0, then 2A is equal to 25,000. Then A equal to 25,000 divided by 2. Therefore, A equal to 12,500. So I'm done with equation 1. I'll move to equation 2, which is 5A plus 2B. 5A plus 2B equal to 48,000. That's equation 2.
Equals to 0.
Okay, so you then say let's A equal to 0. If A is equal to 0, then 2B will be equal to 48,000. Let me write this. Therefore, B equal to 48,000 divided by 2. B
Yes.
equal to 24,000. Now that I have answer for B, I will then say, let me use this other side. Let B equal to 0. If B is equal to 0, then 5A will be equal to 48,000. Therefore, A equal to 48,000 divided by 5. Then A is equal to 9,600. Okay, move to the third equation. The third equation is
2A plus
2A
3B
plus 3B
equals to 39,000.
equal to 39,000. This is equation number 3. Let A equal to 0. Then 3B will be equal to 39,000. Therefore, B equal to 39,000 divided
13,000.
by 3,
That's 13,000.
which is equal to B is equal to 13,000. Then you also say let B
Let's
equal to 0. If B is equal to 0, then 2A will be equal to 39,000. A equal to 39,000 divided by 2. Therefore, A equal to this 19,500. 19,500. Then the last one, equation 4, 2A plus 4B. 2A plus 4B equal to 50,000. This is equation number 4. So let A equal to 0, then 4B equal to 50,000. Therefore, B equal to 50,000 divided by 4. B equal to 12,000. This is 12,500. Please confirm.
Yes.
So you then say, let's B equal to 0. If B is equal to 0, then 2A is equal to 50,000. A equal to 50,000 divided by 2. A equal to 25,000. So with this, we have solved using the elimination method. We have solved all the equations using elimination method. Now, that will take us to the next step. The next step is to construct a pivot table. So, pivot table. The result you have under your elimination is what you are going to use in your pivot table. Okay, so we have A and B. Then we have equations. The first equation is 5A. The first equation is 5A plus
B equals to 2,000 plus B.
Hold on, is it 5A? 2A plus B. Equation 1 is 2A plus B. Okay.
Equals to 5,000.
2A plus B equal to 25,000. Then the second equation is what? 5A.
5A plus 2B.
Let me manage the space. 5A
5A
plus
2B
2B equal to
is 48,000.
48,000. Then the third equation is 2A plus 3B
3B
equal
also
to
39.
39,000. Then the last one is 2A plus 4B equal to 50,000. Okay. Now, we go back to our elimination for the first equation. For the first equation, when A is equal to 0, what is B? Let's go back to the first one. So this is where we started from. When A is equal to 0, B is 25,000.
Yeah.
So A will be 25,000. When B is 0, A is equal to 9,000, no, 12,500. 12,500 is A. So A is 12,500. In the second equation,
12,500.
when A is 0, in the second equation, when A is 0, B is 24,000. A is 24,000. Then when B is 0, A is 9,600. The third equation, when A is 0,
B is 13,000.
B is 13,000. And when B is 0,
B is 19,000.
A is 19,500. In the fourth equation, when A is 0, B is 12,500. And when B is 0, A is 25,000. With this, we have constructed our pivot table. The next thing we want to do is to construct a graph. Number 3, graph. When you want to construct your graph, please don't use you have to use ruler where appropriate. You use ruler. If you are given a graph sheet, that will make life easy for you. But if you are not given a graph sheet, then you have to follow the procedures we are going to use. Okay, then when you want to draw your graph, please don't be too stingy. You have to make it very bold and big. Don't just draw your graph anyhow, the way you normally do in the class when you be dividing one page of your exercise book into 4. So you have to make it very bold and big. So I'm not using ruler here, but let me see. Okay. So let's say this is A axis. This is A axis. This is B axis. So we want to plot A against B. We are going to use the result of your pivot table. All the results you have in your pivot table is what you are going to use to plot your graph. Therefore, now, you look at from grade A, the highest number is 25,000. The lowest is 9,600. Grade B, highest is 25,000. Lowest is 12,500. So this will guide you to be able to scale your graph. Therefore, the highest is 25,000. So we can make each one to be 5,000. All right. So on the day of your exam, make it bigger than this. All right. Make it bigger than this. That's only when you can appreciate it better. So This will be 5,000. Here will be 10,000. Here will be 15,000. Here will be 20,000. Then this one will be 25,000. In fact, I'm even supposed to make it 2 for 1. But in any case, let's see. Then in this one, Oliver, you are the one making noise. So here is 5,000. Say here is 10,000. Here is 15,000. Here is 20,000. Then here is 25,000. So starting from point 0, remember, you don't have negative output. The least you can produce is 0. That's why you are starting from the basis, which is 0. That's the minimum. So from the pivot table, for equation 1, A is 12,500, B is 25,000. So 12,500 is in between 10,000 and 15,000. Here is 12,500. Okay? So here is 25,000. So join the two together. Okay? So write out the equation. This is equation 2A plus B. Equation 2A plus B equal to 25,000. So I'm done with that. Move to the next one.
Hello, sir. Hello, sir.
Yes?
It means that we ignore the zeros in the pivot table for A
What do you
and
want
B.
to follow the way I'm doing? You don't need 0.
Okay.
Next one. A is 96. B is 24,000. 96, 24,000. Okay? A is 96. 9,600 will be somewhere here. For example, here is 9,600. Then B is 24,000. 24,000 will be somewhere here. For example, 24,000. Okay? Maybe I should even use different color so that will be different. Let me see. This will slow down my work. Okay, 24,000. Here is 12,500. Here is 9,600. So that will be different from the normal value that we have there. Okay. Then the next one, we need to join the two together. All right. Let me go back to the normal color. So we join A and B together. Okay. Write out the equation. This is equation 5A plus 2B. 5A plus 2B equal to 48,000. I'm done with that. Move to the next one. The next one, let me go back to red. The next one is, let me make this one to be red. Red, red, then red. Okay. So the next one is equation 3. Just go straight. Instead of it to be saying when A is 0, B is 13,000. When B is 0, A is 19,500. Just go to where you have A indicate 19,500, B indicate 13,000 and move on. So A is 19,500. 19,500 will be somewhere here. 19,500. Then B is 13,000. 13,000 is, say for example, is somewhere here. That's 13,000. Then join the two. Go back to blue color. So 19,500, then 13,000. Okay. Write out the equation. This is equation 2A plus 3B. 2A plus 3B equal to 39,000. The last one is 2A plus 4B equal to 50,000. So when A is 25,000, B is 12,500. Okay. Go to red color. A is 25,000. A is 25,000. Okay. Then B is 12,500. 12,500 is in between. Is somewhere around this place, in between 10 and then 20, and then 15 rather. That's 12,500. 12,500. Closely beside the 13,000. This one is the 13,000. Okay, so join it together. Go back to color blue. So join the two together. Let me see if my hand will be straight. Okay, that's it. That's it. So write out the equation. Let me withdraw that so that it's okay like that. The equation, this is the equation here for clarity. That's the last equation there. Let me even use color red for that. Let me use color red for all those things. This one is equation 2A plus 4B equal to 50,000. This is, what is the first one? The first one I drew. That's 12,500. Okay, okay, this is it here. This is the second one. Then this one here. And this one here. Okay, so that's that. So I've completed my graph. The next thing I need to do now is to find the point of intersection between A and B. All right. When you are maximizing contribution, your point of intersection will be internal. So you are going to look for point of intersection between A and B towards 0. So A and B intercepted at this point where you have 9,600. So let's call it, let's say this is point X. What's wrong with you? This is not connecting. Oh, you're not connecting now. It was my time. Okay, it's back. So where you have this 9,600, let's call it point X. A and B also intercepted at this point here. They intercepted there. Let's call that point Y. A and B intercepted at this point. Let's call it point Z. Then A and B intercepted at this point where you have 12,500. Let's call it M. So there are 4 points of intersection. All what you have internal represent the feasible region. This is your feasible region. All these places are your feasible region because you are maximizing contribution. If you are minimizing cost, your point of intersection will be external, rightward to from 0. Say, for example, you want to minimize cost, you are going to pick these points here as your feasible region. A and B also intercepted at this point here. They also intercepted at this point. Those are the 3 points of intersection if you want to minimize cost, but we are maximizing contribution. That's why you look at the point of intersection towards 0. All right. So the point of intersection is this point X, what you have here, point Y, this one here. Okay. Then point Z, this one, then point M, where you have 12,500. Now that you have determined the point of intersection, the next thing you need to do is to find figure for each point of intersection. So you then do you say at point X, Y, Z, M. We want to determine value for A and B. Okay. Now, at point X, the value of A is 9,600. That's the 9,600 you have here. 9,600. Value of B is equal to 0. Trace it down where you have 0. At point Y is in between. If on the day of your exam, you are given a graph sheet, all you need to do is to place your ruler at that point of intersection where you have Y. You trace it to the left, whatever value you have there, write it down. Then you trace it downward. Whatever value you have there, write it down for B. But in this situation, we are not given a graph sheet. We don't have graph sheet. So we are going to use simultaneous equation to get the exact value for that point. So if you are not given a graph sheet, you can't just draw to the left, trace to the left, then trace downward and say that's the right number. If you get it correctly, you are just lucky. That's not what you are going to do. You are going to use simultaneous equation to get the value. So for point Y and Z, we can't get the value because we have to use simultaneous equation. So you keep it open, just leave it blank. Then move to the fourth one, point M. At point M, A is equal to 0 because that point M where you have 12,500, you can trace it to the left. So that's 0. Then B is equal to 12,500. So before you proceed to solution table, you need to first of all determine the value of A and B at point Y and Z. So let me give you what you need to do. To determine to determine the value of A and B at points Y and Z, the following procedures can be used. Step one. Come up. What's wrong with you? Pen is not okay. It's back. Step one. Identify the equation that intercepts. Step one, identify the equations that intercepts at point Y and Z. That's the first thing you are going to do. Then step two, solve the equations simultaneously. Okay, solve the equations simultaneously. So let's quickly do that. Step one, we need to identify the equations. First thing first, at point Y, here is point Y. Okay, that's point Y there. What are the equations that are intercepted? At this point Y, we have two equations. This equation that went netting 5, okay, netting 5, and then 13,000. Netting 5 and 13,000 is one equation.
Equation
Okay,
3 on
that's
equation
this
3.
equation of equation 3, which
Yeah, and equation 2 and 3 intercepted at Y.
equation 2 and 3, right? Intercepted
Yeah,
at Y.
intercepted at Y. Yeah.
So this let's make it clear. This 19,500 and then 13,000. That is the equation. Which equation is that?
Equation 2 and 3.
Equation 2 and 3. This is equation 2. This is equation 3. This is no. This is hold on. This is equation
Equation
1. This is equation 2. This is equation 3. This is equation 4. Okay. So I'm saying that at this point Y, we have equation 3. Okay. Then there's another equation of this 96 and then 24,000. That's equation 2 and 3. Those are the two equations that are intercepted at point Y. So bring it out. I will then say at point Y, equation 2 is 5A plus 2B. 5A plus 2B equal to 48,000. Then the second one, equation 3 is 2A plus 3B equal to 39,000. I think that's it.
Yeah.
Yes, correct. So the step, we have identified the equation. Then the second step is to solve the equation using simultaneous equation. So this will be equation 1. This will be equation 2. Then we solve using simultaneous equation. So I would then say 5a. When you want to solve using simultaneous equation, you are going to multiply the first equation by the first letter, by the first figure in the second equation. You also multiply the second equation by the first figure in the first equation. So this is what I'm trying to say. Say 2 multiplied by 5a plus 2b equal to 48,000. Next one is 5 multiplied by 2a plus 3b equal to 39,000. Therefore, 2 multiplied by 5 will give us 10a plus 2 multiplied by 2, 4b. 2 multiplied by 48,000, 96,000. 5 multiplied by 2, 10a plus 5 multiplied by 3, 15b equal to 5 multiplied by 39. What do you have there?
195.
195,000. So these two will cancel each other. So 15 minus 4 will give us 11b equal to 195 minus 96.
99,000.
99,000.
So
Therefore,
B
B equal to
is equal to
99,000 divided by 11. B equal to what?
9,000.
9,000. Then you substitute for B in equation 1. Anywhere you see B, you put 9,000. So substitute. For B in any of the equations. So let's use equation 1. Equation 1, we have 5a plus 2b.
Yeah.
5a plus 2 into 9,000. Like I said, anywhere you see b, you put 9,000 equal to 48,000. Okay, is it 48? Yes, it's 48.
Yes, it is.
Then you then say 5a equal to 48,000 minus
Minus 18.
2 multiplied by 9,000 will give us 18,000.
18. Yeah.
Therefore, A will then be equal to 30,000
Yeah.
divided by 5.
Yes.
A equal to what?
6,000.
6,000. So A equal to 6,000, B equal to 9,000. Then you go and put it there. A is 6,000, B is 9,000. So if you are using a graph sheet, at this point Y, when you trace it to the left, it will give you 6,000. If you trace it down, it will give you 9,000. Okay, that's that. Then,
I got 5. Yes, yes,
pardon?
okay. No, I said I without solving it simultaneously. What I first got for A is 5,000 and B is 8,000. Just something close.
Okay.
Mm.
So the next one is point Z. We want to determine value for point Z. At this point Z, there are two equations that are intercepted.
Yeah.
The equation that went, the equation of this 19.5 as 19.5 and 12.5 intercepted at that point.
Mm.
That
So
and that's
equation
equation
3
1,
and
right?
4. No, equation 3 and 4.
3 and 4. Let me see.
Mm.
You know, this is
Equation
point.
1. Equation
This is
1
hold
and
on,
3.
hold on. This is point Z we are looking for. That's the point Z there that we are looking for. So the two equations that intercepted that is equation 1 and 4.
1 and 3.
Yeah, 1 and 3 rather.
1 and 3.
1 and 3. Equation 1 and 3. There is no equation 1 there. Equation 4 and 3. There is no equation. Don't confuse me. This is the point here. Point Z. That's point Z there. So the equation that I intercepted is this 19.5. This 19.5 and 13,000. That's one equation. And that's equation 2A plus 3B equal to 39,000. Equation 3.
3 and 4.
So equation 3 is the one. Then there's another one. This 12.5 and 25,000 is another equation. We trace it down like that. You see that equation of 25,000 and the 12.5. That's equation 4. So equation 3 and 4 intercepted at point Z.
Oh, I don't think so.
So equation 3 is 2A plus 3B. I would then say, oh, despite the, so I'll finish all those, the pages I left. Okay, move on. Let's continue from the other side after the working. So I would then say at point Z, we have 2A plus 3B equal to, is it 2A plus 3B? Yes, 2A plus 3B equal to 39,000. Then equation 4, which is 2A plus 4B. Here is 39,000. Then we have equation 2A plus 4B equal to 50,000. So these are the two equations that are intercepted at point Z. Then you now solve the equation using elimination, using simultaneous. Okay. So of course, in this case, when you look at the two equations, the first figure is 2. The first figure here too is 2. So just cancel each other. There's no need for you to be wasting time. So these two will cancel each other. So that will then be 4B minus 3B will give us B. B equal to 50
11.
minus 39 will give us 11,000.
11, yeah.
Okay. Some people will still be asking me, how did I get 11,000? So let me just write it out. 4B minus 3B equal to 50,000 minus 39,000. Therefore, B equal to 11,000. Substitute. For B in equation 1. So in equation 1, we have 2A plus 3 into 11,000. Like I said, anywhere you see B, you put 11,000 equal to 39,000. Okay, therefore 2A equal to 39,000 minus 33,000. 3 multiplied by 11 will give us 33,000. Therefore, A will then be equal to 39 minus 33 will give us 6,000. 6,000 divided by 2. Therefore, A equal to 3,000. Okay. A equal to 3,000. B equal to 11,000. So let's go and put it there. 3, then 11. Here is 3,000. Here is 11,000. Linear programming is very straightforward, only that it takes time. If guys, and then that's why I always advise students that don't make it your first attempt. okay? Because it will waste your time. You may spend 1 hour plus, you won't know that you are still there. You'll be happy. Your answer booklet will be full up. You'll be happy that you have done something. Meanwhile, you are just solving only one question yet. And then until the invigilator will tell you that 30 minutes more. How do you want to spend 30 minutes to answer 4 questions? So you have to be very careful. Don't rush it. Okay. So you can see for this point Z here, if you trace it to the left, you are going to get 3,000 for A. If you trace it downward, you are going to get 11,000. You are going to get 11,000 for B. So now that we have gotten value for each of them, the next thing we want to do is to determine the solution table. We need to construct a solution table. Okay. Solution. That should be number 4 after the graph. Yeah, that's number 4. Solution table. Okay. Yeah. So the first item will be your objective function. In the objective function, we have 612 of A plus 456 of B. Then we are going to have the total. So at point X, Y, Z, M, we want to determine the quantity we are going to produce for each product. That will be the optimal production plan. Okay. So at point X, based on the figures we got after the graph, at point X,
9,600.
A is 9,600, B equal to 0. 9,600, then 0. So what this simply means is that you are going to multiply the contribution of each of them, which is 612 multiplied by 9,600 plus 456 multiplied by 0. Give me the answer. Then for Y, 612 multiplied by, is it 6,000? We got the other time. Let me confirm.
6,000,
Yes,
9,000.
6,000, 9,000. Yes. So 612 multiplied by 6,000 plus 456 multiplied by 9,000. Give me the answer. 612 multiplied by 3,000 plus 456 multiplied by 11,000. Then the last one, let me write this. The last one is 612 multiplied by 0 plus 456 multiplied by 12.5. So give me the answer for each of them. Yes? Yes? Give me
For the
answer.
first one, sir, for X, sir,
Yes?
5,875,200.
5,000,000.
875,200.
Okay.
Last one,
875,200. The last one,
The second
five
one.
thousand 5,700,000.
Okay, 5.7. Okay.
The second one.
Yep.
5,040,000.
5 million.
40,000.
Are you sure? Do it again.
Yeah. The second one.
I got 7,776,000.
You are correct. 7,776,000. That's the answer. What about Z?
Somebody is working on it.
Z?
6
6,852,000.
6 million.
6
800
million 852,000. 852,000.
852,000. Okay, thank you. So when you look at the figures that we got, the total contribution that we got, you will notice that point Y has the highest contribution. Point Y has the highest contribution of 7,776,000. That is the optimal level of activity. That's the optimal level of activity. You then say production plan, optimal, number 5, optimal production plan. So our optimal production plan is that the company should produce 6,000 units of A and then 9,000 units of B. Okay. So products A, then B. So for A, we are producing 6,000 units. For B, we are producing 9,000 units. So if you want to put it in words, you can say, oh, Oshimiri, Nigeria Limited. Oshimiri Nigeria Limited should produce 6,000 units of grade A and 9,000 units of grade B in order to maximize monthly contribution of 7,776,000. That's it. That's not the last thing. Examiner also told you to determine the profit derivable. You can see that's why I was complaining the other time that this is too small for 5 marks. All right. So number 6, profit derivable. Monthly profits. Remember, profit is contribution less fixed cost. So contribution, monthly contribution is 7,776,000. The fixed overhead, the monthly fixed overhead, we are told is 2,600,000. Therefore, the profits will then be equal to 5,176,000. That's it. If you do this from beginning to this point, it's just 10 marks. You can imagine, with all these stress things, it's just 10 marks. So that's that. Let me know if you have any question before we move to the second, the other part of the question, number C. Okay. Now, number C requirement of the question. You have to explain the concept and significance of dual price. Dual price is the same thing as shadow price and slack variable in the context of the model used by the company in this scenario. Just explain what is shadow price. How do you determine shadow price? And that's all. You earn your 4 marks. All right. Then number D, you have to calculate the dual price for the constraints and identify the constraint identified in this scenario. There are 4 different constraints in the question. There is constraint for material kilogram. There is constraint for skilled labor hours. There is constraint for unskilled labor hours. There's also constraint for machine hours. However, examiner wants you to calculate dual prices, that is shadow price. So you want to calculate shadow price. How do you determine shadow price? Like I mentioned to you, you can either use dual method or increase the number of constraints by 1. Whichever method that you use, you are going to get the same answer. So you want to calculate shadow price. Let's continue. I would then say calculating number D, calculating shadow price. Requirement C, then requirement D. So that requirement C, I've already told you, just explain the concept of shadow price. Shadow price represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. All right. So you then begin to say 1 or 2 things in addition to that. So examiner says you explain the concept of shadow price and its significance. So I will show you later on, but first thing first, let's solve the one that has to do with calculation, which is D. So you want to determine shadow price. So I will then come here, calculating shadow price. We won't be able to solve more than 1 question. You can see, it's only 1 question we'll be solving since. So we don't have time, we still have a lot to do. All right. So what I will do is that in my normal class, I will just solve using another question. So I will share the video with you. So that will be an additional illustration for you. We still have a long way to go. And we have just about 1.5 months. Okay, so we want to determine shadow price. On the day of your exam, please don't go and say using dual method or increasing the number of constraints by 1. Just go ahead, solve whatever you need to do. If you do it, examiner will not penalize you, but it's a waste of time. All right, just use whatever method that you want to use. But for the purpose of this class, I will indicate it. So solve using dual method rather. Okay, I want to use dual method. Using dual method to determine shadow price, there are about 3 or 4 procedures. The first procedure, let me give it to you, then I will give you the procedure, then I will solve. The first procedure is to identify the equation that intercepts at the optimal level of activity. Okay, step 1, identify the equation that intercepts at optimal level of activity. How do you do this? Then go to the question. At the point where we made a decision, that is point Y. At this point Y is the optimal level of activity, where we said that the company should produce 6,000 units of A, 9,000 units of B. That's your optimal level of activity. So that's where you are going to see the shadow price. All right. So at that point, what are the equations that intercept at that point Y? These are the 2 I think we have identified it before. I think so. Yes. We have identified, this is the point Y here. That's the point Y. So equation 5A plus 2B equal to 48,000, 2A plus 3B equal to 39,000. So those are the two equations. At point Y, optimal level. Okay, at this point Y, we have 5A plus 2B equal to 48,000. Then we also have 2A plus 3B equal to 39,000. I hope that is it. Let me confirm. At point Y.
Yes, 39,000. Yes, sir.
39,000, right?
Yes, sir.
Yes, okay. So that's the first thing you are going to do. You identify the equation at the optimal level of activity. That's the first thing you need to do. Then step 2, you find the transpose of the original problem, okay? Find the transpose of the original problem or matrix by changing row to column or column to row. So let's do that. Here is the original problem, okay? Find the transpose. When you find the transpose, what that simply means is that you are expected to find the dual. That is, find the dual problem. Okay, so how do you find the dual problem? First thing first, you need to bring out the original problem. Original problem or matrix. The original problem is 5A plus 2B. 5A plus 2B equal to 48,000. Then 2A plus 3B equal to 39,000. That's the original problem. Then you now include the objective function, which is 612 of A plus 456 of B. So this represents the original problem. Then you now find the dual. Find the dual problem. So dual problem. To find the dual problem, simply change row to column or column to row. The first one, this is the first row. You change it to column. So this will then be 5 to 48,000. The second row, change it to column. This will be 2, 3, 39,000. The third row, change it to column, which is 612, then 4, 5, 6. This is the dual problem. Now, when you look at the first problem, we have letter A and B. As you are finding the dual, you are supposed to change the letter. You can't use A and B again. You can use X and Y, M and N, any letter that is different from the first one. So let's use X and Y. X, Y, X, Y, X, Y. So plus. So that's that. With this, we have found the dual problem. This is how to find the dual problem. Then step 3 is to solve the dual using solve the dual simultaneously. Step 3, solve the dual problem simultaneously. Okay, so this is the dual problem here. Let's solve it simultaneously. Then say, you notice that the constraint we have before of 48,000, this constraint of 48,000, 39,000 has now turned to objective function. Meaning that if before your objective function is to maximize contribution, as you are finding dual, it now become minimization of cost. Okay, so everything you have in the original problem must change. But again, we don't need that information just for information's sake. We are not solving it for anything. So the dual problem is 5x plus 2y equal to 612. Then 2x plus 3y equal to 456. Equation 1, equation 2. So we need to multiply the first equation by 2. So 2 multiplied by 5x plus 2y equal to 612. You multiply 5 with the second equation, 2x plus 3y equal to 456. So 2 multiplied by 5, it gives us 10x. 2 multiplied by 2, 4y. 2 multiplied by 612, what you get?
1224.
1, 2, 2, 4. Then 5 multiplied by 2, 10x. 5 multiplied by 3, 15y. 5 multiplied by 4, 5, 6. What do you get?
2,280.
280. So this will cancel each other. 15y minus 4y, 280 minus 1224. This is 11y equal to, what do you have there?
56.
1,056. Therefore, y equal to 1,056 divided by 11. What you get?
96.
96 naira. Then substitute for y in equation 1. In equation 1, we have 5x plus 2y. 5x plus 2 into y, we got 96. Anywhere you see y, you put 96. Let me write it. Equal to 612. Therefore, 5x equal to 612 minus 2 multiplied by 96.
192.
192. Therefore, x equal to 612 minus 192.
220.
420
20.
divided by 5.
84.
X is equal to 84. Therefore, shadow price Now, let's go back to our equation, that original problem. This 48,000, I think that is the skilled labor, right? This is the skilled labor. That's the constraint, the first constraint, skilled labor.
Yes, scalable, yeah.
This 39,000 is on skilled labor. Am I correct?
Unscalable, yes, that's true.
Okay, then. Therefore, the shadow price for skilled labor is 84. Unskilled labor is 96. You remember, we said shadow price represent the extra contribution derivable from the additional unit of limited scarce resources that have been fully utilized at the optimal level of activity. So at the point where we made the decision, which is point Y, the two constraints we have there is skilled labor as well as the unskilled labor. Under the skilled labor, you can still make extra contribution of 84 naira. Then under the unskilled, we can make extra contribution of 96 naira. This is how to calculate shadow price. So if you want to increase the number of constraints by 1, let me just use my golden book, my performance management golden book to explain that to you because of time. We have about a few minutes to the end of the class. All right, let me stop sharing this. Before that, do you have any question for me? Some of you have disappeared. No worries. Any questions so far? Okay, so let me quickly stop sharing this and move to let me share the material with you so that we can round up this topic. So in our next class, please go and study CVP analysis, cost volume profit analysis. That's the next topic we are going to treat. Okay? Let me know if you can see my screen, please.
Yes, please.
Okay, so let me use this material to explain. Let me get that. I think that's a question on Shimmery. Okay. Shimmery. That should be illustration number 7 or 8. Let me just okay, not this one. Okay, I think that no, this is 2021. No, this one. Where are you now? Okay, I think this. Okay, this is the question. Now, let me. For that number C requirement of the question, just want to show you the concept and significance of shadow price. So shadow price is described as the extra contribution derivable from the additional unit of limited scarce resources that have been fully utilized at the optimal level of activity. Shadow price represents the amounts a company is willing and ready to pay for the use of an additional unit of a constraint. That is the concept of shadow price. Then what is the significance of shadow price? The following are some of the uses or importance of shadow price. 1, it is used to determine the extra profits achievable from additional unit of a constraint. Number 2, it can be used to determine the maximum amount that a company is willing to pay for a scarce resource. Then number 3, it can be used to determine the sensitivity margin of a scarce resource. Then lastly, it can be used, it is suitable for determining shadow price. You can use shadow price to determining transfer price. Okay, so that's that. So that answers number C. Then we have solved number D. Okay, so this is the number D. This is it, what we just solved. Then the number E part of the question, examiner is asking you to provide how you the courses of action that can be taken to overcome capacity constraint. You know, we have material kilogram. We are told, according to the question, that material kilogram is limited to 25,000. Skilled labor hour is limited to 48,000, and skilled labor is limited to 39,000, and the matching time is limited to 50,000. So examiner is asking you, how can you overcome the constraint on material? How do you overcome the constraint on labor hour or on matching hour? That is what examiner wants you to do. Before I answer that, yes, Latif.
Sorry, sir. I raised the hands in advance. It will be what I will say at the end of the class.
Okay. So the first one, the company can borrow loan to buy additional material. You know, we are told that the material is limited to 25,000 kilograms. So how do you buy the exact material that you need? Because that 25 kilogram is not sufficient. That's what the company has, which means there is a constraint. So how do you overcome the constraint? To overcome the constraint, the company can borrow loan to buy additional material X kilogram needed to maximize contribution towards profit. Though, examiner is also asking you, what are the likely costs that the company will incur? Though this may result in interest expense being incurred on the loan, because when you borrow loan, it's not for free. You have to pay interest. So that interest is a cash outflow. It's a cost to the company. Then number two, the company can outsource production capacity to a reliable supplier. However, this may increase production costs, lower quality of the industrial varnish grades, loss of proprietary technology, and impair the reputation of the company, especially if the supplier cannot deliver according to specification. So instead of buying all those, instead of buying the material kilogram or expending energy of your workers, you need labor hour, you need a machine hour, and all of that. Why don't you just outsource the production capacity to a reliable supplier? You outsource it. Once you outsource this, you are less concerned with the material you want to use again. You are less concerned with the constraint on the labor hour, because it is your supplier, it is your reliable supplier that will be taking care of that. But that will not come for free, because if you outsource it to outside supplier, your production cost may likely increase. Okay, your production cost may likely increase. The quality that the supplier will produce may be lower than what you yourself would have done, how yourself would have done it. Then also, it is possible that you are going to give out your proprietary information, your technology involved, the underlying technology of your products. You may likely give it to the supplier so that you can produce close to how you do it. Then the company may lose that proprietary information, because if your proprietary information is linked to your competitor, the company may be out of the business. And again, when you give it out to a supplier, it may impair the reputation of the company. All right, the reputation of the company may be damaged if the products, if the customer does, the customers do not like the product, or there is an issue that relates to the product. It can impair erode the reputation of the company. Then number three, ways of overcoming the capacity constraint is that the skilled labor can work overtime to meet the required labor hour. Remember, the skilled labor hours available is 48,000. So to overcome that, the workers can work overtime, but that overtime is not for free. The extra labor cost will be incurred to compensate for the extra hours worked. Once you work on overtime, certainly you are going to earn overtime bonus. Then number four, the company can hire additional labor to meet the required labor capacity. This will mean additional labor costs will be incurred. So that's another point. Then the fifth point that I made is that the capacity of the machine can be increased to enable shift work. This may increase productivity, but may result in additional overtime costs being incurred and may lead to machine breakdown due to excessive usage. All right. So that's another point, how to overcome the capacity constraint in relation to the machine hour. Then the last point that I made here is that the machinery that can produce better and high quality products with increased operating efficiency should be purchased. All right. This will increase productivity, but may result in a significant investment in non-current assets. So that's the cost that the company will incur, because you need to pay, you need to purchase the new machinery. All right. So these are the points I made in relation to the number E requirement of the question. So it is only when you do all of this that you are going to earn your full mark. That is only when you are going to earn your full mark. All right. So that is the end of the question. That's the end of the question. So Ablatif, you said you have one. You said you have a question for me.
Yes, sir. Thank you so much.
Yeah.
As much as I know that you work time on to time so that we can meet up with the target for midnight.
Yep.
So I have to let you know that we equally go through certain challenges that is out of our own control.
Okay.
And a major of it is from your own ends. I know that the video class that the video you record, right? You still have to refine it before you upload it online. And the time taken to do that before you upload it, usually too long. We want to plead that even that we want to upload it online, you give us raw, like this one now. I bet you we have to go through it again so that we can get all this needed information very well before the next topic, so that it will not be piling up. Please, sir.
No problem. I will talk to admin. All right. So you can also comment in the PM group. Okay. Comment on the PM group. I will appreciate that you have this video on time. Okay. Yes, go ahead.
I usually noticed that Mr. Wasil don't usually find with our complaint.
The issue is that it takes time. You know, when you finish class like this, you know, before you upload on the YouTube, let me stop sharing this. Hold on first. We'll come back to your question. Let me stop this. Let me just pause.